Hi everyone. Today we'll be discussing the LeetCode problem of the day. Find resultant array after removing anagrams. In this problem, you are given a zero indexed string array words where words of I contains lowercase English letters. In one operation, you can select any index I in the word's length, and also and if words of I minus 1 and words of I are both anagrams, then you can delete words of I from the array. And you can keep performing this operation as long as you can select an index that satisfies this condition. And at the end, you just have to return the words after performing all the operations. And it can be shown that selecting the indices for each operation in any order will lead to the same result. And an anagram is a word phrase formed by rearranging the letters of different words or phrase using the original letters exactly once. So that means if you want to check if two words are anagrams, so in this string, if we rearrange the letters in some order, and if we are able to reach the first word, then they are anagrams. So for example, if ABCD, we can rearrange this as DACB. And another example can be if we have ABBA and then AABB. So these both are also anagrams because we can rearrange this to form this word. But if we have this, so these both are not anagrams because no matter what we do, we can't rearrange this to make this because we have an extra C here. So let's see the first example. So we have these words. So suppose if we pick this index, so words of I and words of I minus 1 both are anagrams. So we delete words of I. And then suppose we pick this as our I, then these both are anagrams, so we delete this. Then if we pick this, so these both are not anagrams, so we don't do anything. Now if we pick this, so I and I minus 1, this is I minus 1. So these both are anagrams, so we delete this as well. So the resultant array is just A, B, B, A and C, D. So this is the output. Now for the example 2, we can see that the words are A, B, C, D and E. So no consecutive words are anagrams. So we can't do any operations. So we just return the array as it is. Now let's go over the approach. Suppose we have an array of words like this. So these three are anagrams. And then maybe we have these two words which are anagrams. And then maybe this word. And finally, we have these four words as an anagrams. So if this is our input array, now let's just look at this, for example, these two words. So here, since if we have words of I and words of I minus 1 as anagrams, we always delete words of I. So if these both are anagrams, we delete the right string. So for this string will be deleted. Now if we see for the first consecutive anagrams, we can see that only the first string remains and the other two gets deleted because of this property. If words of I and words of I minus 1 are anagrams, words of I minus 1 remains and words of I gets deleted. So out of these three, if we check these two, so this will get deleted, and if we check these two, this will get deleted. Or if we change the order as well, if we check these two, this will get deleted. Then if we check these two, this will get deleted. So we can say that at the end, only the first one remains. So the other two gets deleted. And for this, we have only one, so we can't delete anything. And for the last one, all the last ones get deleted, only this stays. So at the end, result is this, this, and this. So the result will contain these 4 strings. So one way we can think of is, first, when we have an array, we know for sure that this element will be present in our answer, because we can't delete this string because there's no string to the left of it. So once we have this in our answer, and we'll start iterating on the rest of the rest of the strings. And yeah, suppose, let's remove this. Yeah, so first you have this in your answer, and then you start iterating from here. So once you start iterating, you'll first check if the current string and uh, the last string in your answer is anagrams or not. So if they both are anagrams, then you skip this and you move forward. So again, the same thing, you will check the current string and the last string in your answer. If these both are anagrams, then you skip. And then you move here. Now you can see that the current string and the last string in your answer is not an anagram. So you add this in your answer and you repeat the process. So you're right here. Now these both are anagrams, so you skip this. And then you move here. And now green and the last string is not an anagram, so you add this in your answer and you repeat. So again, this yellow string is yellow string and the green string are not an anagram, so you add this. And when you move forward, the remaining strings are anagrams with this, so you won't add any of them. So at the end, this is your answer. Now, to check whether 2 strings are anagrams, we can use a frequency array. So that means if we have a string A, B, B, A, and D, and another string as, let's say, B, D, A, and B. So we can see that these 2 strings are anagrams, because if we rearrange this string, we can make it A, B, B. Okay, we need one more A here. A, B, B, and then 2 A's and D. So if you rearrange this string, you can reach the first string. So these both are anagrams. And if both 2 strings are anagrams, then the frequency of all the characters in the 2 strings will be same. So that means in this first string, the frequency of A is 3, the frequency of B is 2, the frequency of C is 0, frequency of D is 1, and E is 0, and so on till Z equal to 0. And for this, we can create a frequency array. Similarly, A will be 3 times, B is present 2 times, C is present 0, and D is present once, E is 0, up to Z. So if we see, A is matching, B is matching, and all the characters are matching. So if the frequency is matching for all the characters, the 2 strings are anagrams. So yeah, that's the approach. You will first keep the resultant array. In that, you will add the first string. So you'll add this, and you will keep comparing with the remaining strings. If the current string is equal to the the last string in your answer, if the both are anagrams, you will skip it. Otherwise, you will add it. Now let's code the approach. So first, let me create a list of string for the answer. And in this, we know that the first word is will always be present. So we can't delete the first word. So let's add it. words of 0, and then we can iterate on the remaining words. So now you just need to check the frequency of the current word is exactly equal to the frequency array of the previous word. If they're not equal, then you can add it. If they're equal, you can skip the current word. So let me create a frequency array for the first word, and let's say previous frequency. Find frequency words of 0. We'll just create a function to create the frequency array. Find frequency. The size will be 26 because the string contains only lowercase alphabets, so from A to Z. So for each character, suppose we have a character C. So from C, we'll subtract A, which will give you C minus A will give you 3. Sorry, 2. So the character C will be stored in index 2. So in the same way, B will be stored in index 1, A will be stored in index 0, and Z will be stored in index 25. So this is how we create our frequency array. And at the end, return answer, not answer, frequency. So we have the previous frequency. So let's also find the current frequency. Find frequency words of I. Now let's say if check okay, if both frequencies are not equal, then you'll add your words of I in your answer. So answer.add words of I. And since you're adding words of I in your answer, the previous frequency will be the current frequency. So we are storing this previous frequency because in each iteration, we don't want to calculate the previous frequency again and again. So that's why we store it. And we only calculate the current frequency each time. And at the end, return answer. We also need to fill this check function. So for that, boolean so we just need to check if all the frequencies in both the strings, both the arrays are same. So let's just iterate on it. 6. If any frequency of if frequency of any index is not matching, we can directly return false. And at the end, if all are matching, then return true. Okay, works. Let me submit. Yeah, it works. Now let's do the time and space complexity analysis. So for the time complexity, we have we are iterating on the words array, and in each iteration, we are finding the frequency, and finding the frequency will have the time complexity of the size of the word. So this loop will be order of n, and this loop will be order of size of the words. And again, we have a check. So check will be just order of 26 because we are just iterating on all the indexes from 0 to 25. So overall complexity will be order of n into the size, the word's length. So n is 100 and the word's length can be up to 10. So overall it should be 1000. And for the space complexity, we're just creating an array of size 26 and we are doing it total n times. We can say space complexity is order of n. Yeah. And I also have the code in Python. If anyone wants to view it, I'll add it in the description as well. And let's catch up in the next video.